a team of Purdue University engineers has discovered that a type of fabric typically used for hiking gear has remarkable heat conducting properties on par with stainless steel, potentially leading to wearable electronics that successfully cool both the device and the wearer's skin. As smartwatches become more powerful, they will generate more heat. This material will be useful to prevent burns or rashes. The material is made of ultra-high molecular weight polyethylene fibers, which are sold commercially under the brand name Dyneema. These polymer-based fabrics are marketed for their high strength, durability, and abrasion resistance, and are often used to create body armor, specialty sports gear, ropes, and nets. Purdue heat transfer researchers recently investigated other uses for the fabric, namely as a cooling interface between human skin and wearable electronics. Their research is published in the journal Scientific Reports. The researcher says that this fabric has great flexibility and thermal properties. If a material has a high thermal conductivity, that means heat dissipates through the material more easily. There are many heat dissipation methods for fabrics, from the simple mitre wicking to the intricate conventional fabrics with heat conducting strands woven in, to the very complex liquid-cooled garments worn by astronauts. The researcher says that our next smartwatch or virtual reality headset could be more powerful than our current smartphone, so they need to dissipate heat away from the electronic components to keep the wearer comfortable. These polymer fabrics have amazing thermal properties that can keep these devices cooler and avoid low-degree skin burns. The team discovered these properties by benchmarking Dyneema against conventional cotton fabrics as well as polyethylene sheets in rigid non-woven form. They obtained several different commercially manufactured fabric samples and even wove their own samples from raw Dyneema fibers. The researchers tested the fabric samples at the Birk Nanotechnology Center in Purdue's Discovery Park. The samples went into a small vacuum chamber with a metal wire laid across the surface as a heat source. Using an infrared microscope, they could generate detailed data about how much heat was being conducted through the fabric surface and in which direction. They found that the Dyneema fabric has 20 to 30 times higher thermal conductivity than other fabrics comparable with steel. The team also tested the fabric's flexibility, which is important for wearable electronics. The researchers say that these polymer fabrics are in the sweet spot of having good conductivity and good flexibility. The fabric naturally has these properties with no additional circuitry or other equipment, but the researchers also have plans to test how weaving in different materials affect the fabric.